Okay, looking at 286A, what two numbers are being multiplied using the rectangle? How can you tell? All right, first thing I'm going to look at are these two numbers. They're small. So I have 20 and I have 6. So I know 3 times 2 is 6. That's the only way to get 6. And I see that the 20's up here. So I know 2 goes up here, 3 goes over here. Now I can look at my 150 and my 500. Or what times 2 equals 20, which is 10. 10 times 2 is 20. Now I have to look at 10 times what is 500, which is 50. So there's my 4 numbers. What two numbers are actually being multiplied? It's 52 times 13. How can I tell? Well, you're just going to have to write explanations. I guess I can write 3 times 2 is 6. So the 2 must go on top. To make 20. All right, going on, write the product as a sum. The product is the answer. So we literally just write 500 plus 150 plus 20 plus 6. And if I added all those up, I get 676.
Wait, I thought it was 680.
Going back to C. C's below here on my worksheet.
Oh, it is.
But I'm going to
Never mind.
write it out as the distributive property. There's 2 ways we can write it. We can write it as 52 times 10 plus 3. Or I can simply write it as 13 times 50 plus 2. Either way is correct. And that is for C there. All right, looking at the next, we have to draw either a stem and leaf plot or a dot plot. And the question asks you again, a lot of numbers have a small range. So when we have a small range, we probably want to stay away from the stem and leaf plot because we're going to be repeating numbers a lot. So we're going to make a dot plot. Easiest way to do it, start with the straight line. Looking at our numbers, we have 8, 9, 10, and 11. So we just simply write 8, 9, 10, 11, and 12. Going through the 8s, if I counted up all my 8s, marked them off as I went, I would count 5. So just 5 dots. I count up all my 9s, I would only have 3 dots. Counted up all my 10s, and I believe there are 8 10s for 8 dots.
Oh, yeah.
Count up my 11s, and I have 6 total. And count up all my 12s, and I should have 4. Again, we want to use the dot plot. The stem and leaf plot wouldn't work. You'd have everything from 8, 9 on the 0. You'd have 8, 8, 8, 8, 8, 9, 9. You probably wouldn't want to use it. You'd be repeating. Harder to count how many 8s and how many 9s. All right, moving on to 88. It's pretty much just a guessing game. So 288, the following line, what's missing? So I can look at the space between 12 and 20. But I also look between 20 and 24. I notice there is a gap of 4. So I'm just going to go backwards. 20 minus 4 would be anyone in here?
16.
16.
Good job.
So 12 minus 4, 8, 8 minus 4, 4, 4 minus 4, 0. Pretty easy one, basic one. Then look here, I have 10 and I have 60. I look at the gaps. Just looking for a pattern here. I'll try by 5s, 10, 15, 20, 25, 30. That wouldn't work. Anyone back there, what works?
It's going by 10s.
Going by 10s. So 10, 20, 30, 40, 50. Simply I could have took my 60 and counted 1, 2, 3, 4, 5 and divided it. Actually, it would have been 1, 2, 3, 4, 5, 6 gaps, and you would have gotten your 10. Alright, moving on to the last page, I think. I have 2 more, C and D. I have 13 and 41. Maybe I want to look at if it's going up by 15s or by 5s. I don't know. If it was 13, 26, looks like I'm going to hit 41 over here, so it's probably not that. If I had 5s, 18, that's not going to work, but I'm close. So I found out the pattern is going up by 6s. So it's 6, 13, 20. Actually, looking at this, it's not going up because that would be 26 and 32, so that's not the right way. I believe it's going up 6 plus 5, so this one's going up by 6, 7, 8, 9. And I screwed it up again here. It's going up by 7s. It is going up by 7s. The 6 tricked me out there. So plus 7 is 20, plus 7 is 27, plus 7 is 34, plus 7 is 41. That's what happens when you're doing it live, huh? Make more mistakes. We're human. Looking here, I see patterns of 5s, so that's good. And guess what? That is our pattern. 15, 20, 25, 30, 35, 40, 45. Looking at 89. Easiest rule for this. Okay, my main rule for this, and you're going to do a lot of this in 7th grade, is what you do on top, you do on the bottom. If you do the same thing on the bottom, you always do it on the top when you're getting equivalents. So like right up here, they times them both by 4, you got an equivalent. You can't get an equivalent if you multiply by different numbers. For example, if I had a half and wanted to get an equivalent, I would multiply both of them by 2 to get 2/4. Same thing. If you had 2/4 of a pizza, you have half. It's the same thing as if I colored in the whole square there. So then I look at here. I have 80 over 100. Somehow they are decreasing that to something out of 10. All right? So they're getting it into lowest terms. I know how many 10s I can work backwards. 10 times what is 100? So I can do 10 times 10 is 100. And what times what is 80, which is 8 times 10. Or we could have divided both sides to get 10 to get 8. So 8/10 is equal to 80 over 100. Next one, I got a half. What's half of 250? So I can multiply 2 times 125. And if I multiply 1 by 125, I get 125. So those are equivalents again. So what you do on top, you do on the bottom. What you do on the bottom, you do on top. Never forget that statement. You can't get it wrong this year and next year. Going into the last ones is our decimal problems. We've been working on these all chapter long. They've popped up, popped up. The hardest one is D. So I'm going to start with D and make my way up. If I can find my eraser here.
Wow.
So the most important thing, like they tell you on the top, is to line up your decimals. So looking at D, I have 90 minus 903 thousandths. So 90 would have a decimal here because it's a whole number. And I'd have 903. Anytime I have missing places, I add zeros. Keep them in line. Easiest way to do it. So look, we have to borrow because you have 0, can't take away 3. We have to carry again. This becomes a 9. Carry again, becomes a 9. Gotta borrow from here, becomes a 9. Borrow from here, becomes an 8. So again, simple subtraction. 10 minus 3 is 7. 9 minus nothing is 9. 9 minus 9 is 0. Bring down your decimal when you're adding, subtracting. The decimal never moves unless you're doing multiplication or division. 9 minus nothing is 9. 8 minus nothing is 8. So you have 89 and 97 thousandths. That's D again, right down here. Going to C, I'm just going to make my way up again. Again, line up your decimals, 0.275 and 27.5. Again, my decimals are lined up. Add 2 zeros, why not? We're adding 5, 7, 7, decimal, again, comes straight down, and 27. Alright, working with B, we're subtracting. You're probably getting sick of my voice saying line up your decimals. 375 thousandths. We subtract. 2 zeros. Have to borrow. Have to borrow. Have to borrow. Have to borrow again. 10 minus 5 is 5. 9 minus 7 is 2. 11 minus 3 is 8. Bring down my decimal. 8 minus nothing is 8. We got one more left, which is A again. Line them up. Use this one on the paper. 9 plus 3, 12. Bring down my decimal. 8, 10, 11, 12. Carry my 1. 32 and 25 hundredths.
Okay.
So DVD, that's all, folks. Sorry for the chaos. It's all Wilson's fault.
Oh, my.